Hello everybody, I hope you are fine. In this video I'm going to show you how you can examine nonlinear relationships as a kind of robustness check using a smart PLS in the context of pls-sem. So there are 2 points that I need to highlight here first. Number one is that nonlinear relationships occur quite frequently but are generally hard to determine a priori on theoretical grounds. And number two is that linear relationships often approximate nonlinear relationships sufficiently well. Basically, you can consider two types of nonlinear relationships. Number one is quadratic effects, and this is the formula for quadratic effects. And when the relationships between the variables x and y is nonlinear and negative, then you can expect a curve like this or a curve like this, depending on the sign of P1 and P2. And in case that the relationships between variable x and variable y is positive, again depending on the sign of P1 and P2, you can expect to have a curve like this one or like this one. So you can simply model quadratic effects in a smart PLS, and it's quite straightforward, and I will show you how it can be done. The other type of nonlinear relationships between two variables are cubic effects, and here when the relationship between two variables is negative, you can expect to have a curve like this, and in case that the relationship between these two variables is positive, you can expect a curve like this one. And in this slide, you can see one example based on real data. In fact, in this figure, you can see the relationships between positive affect and job performance. You should know that there is a strong theoretical grounds for the nonlinear relationship between positive affect and job performance. In fact, based on affective events theory, job performance is considered as an affect-driven behavior, and since affect fluctuate over time, then the relationship between these two variables can be expected to be nonlinear. So the linear relationship between these two variables is represented with this red line, and the significant nonlinear relationship between these two variables is represented with this blue curve. And given the fact that the interpretable area for this relationship is from 0 to 1, so basically you can see that this line and this curve are not much different from each other, and as I mentioned, in majority of the cases, linear relationships can approximate nonlinear relationships quite well. The other point that I need to highlight here is that implementing quadratic effects in a smart PLS is quite straightforward. Basically, there are three approaches to do so. One of them is the two-stage approach, the other one is the orthogonalizational approach, and the third one is product indicators approach. And among these three approaches, the recommended one is the two-stage approach. So in our example, I'm going to model the quadratic effects based on the two-stage approach. And finally, you should consider these values that are listed here as the thresholds for reporting the f-square effect sizes of the quadratic effects. And basically, these values are based on the work by Kenny in 2015. Now let's go to a smart PLS, and I'm going to show you how you can model quadratic effects in a smart PLS. Alright, so this is our model, and as you can see, we have two predictors. One of them is communication skills, that is a formative construct. We also have creating value, that is a reflective measurement model. Both of them predict job satisfaction and also work motivation. In addition, there is a causal relationship between job satisfaction and work motivation, and age serves as a control variable in our model. Now to create the nonlinear relationship between creating value and job satisfaction, what I can do is that I can simply right click on job satisfaction, and then from this menu I'm going to select add quadratic effect. Then from this menu I'm going to select creating value, because I'm going to define the nonlinear relationship between creating value and job satisfaction. By default, the two-stage approach is selected. Here also I don't need to change anything. So I hit OK, and now the quadratic effect between creating value and job satisfaction has been created. Let me just rename this. creating value to job satisfaction. Alright, now let me create the nonlinear relationship between job satisfaction and communication skills. Again, I right click on job satisfaction. I select add quadratic effect, and this time I select communication skills. I don't need to change anything here, and again I hit OK. Alright, let me just rename this. Communication skills to job satisfaction. Okay, now we focus on work motivation. First, let me create the nonlinear relationship between communication skills and work motivation. So I select communication skills. Let me rename this. Communication skills and work motivation. Alright, let me create the nonlinear relationship between creating value and work motivation. Creating value and work motivation. And finally, I'm going to create the quadratic effect between job satisfaction and work motivation. Job satisfaction to work motivation. Okay, and now what I need to do is to run the bootstrapping routine. Again, make sure that you select 10,000 subsamples, and it will be a basic bootstrapping, and make sure that you select percentile bootstrap. It should be two-tailed, and also the significance level should be 5%. So I hit start calculation. So this is the result, and as you can see, none of the quadratic effects are statistically significant, which means that the relationships between the latent variables are in fact linear. You can see the confidence intervals for these pass coefficients. For the pass coefficients here, so the lower bound and the upper bound of the confidence intervals are displayed here. We also need the f-square effect size of the quadratic effects, and to get these statistics, you can simply click on calculate and then run the model again. And this time I click on f-square, and here again you would be able to see the f-square effect sizes of the quadratic effects. So these are another 3. Alright, now what you need to do is to copy this information into one Excel file and create a table to report in your manuscript or your thesis. So I have already done this. Let me just show you how you can report the results of this analysis. As you can see, I have created a table with a few columns. I have the effects, the nonlinear effects here in this column. I have the coefficients for these effects. I also have the confidence intervals, the t-statistics, and the p-values. And you already know that the confidence intervals, the t-statistic, and the p-value communicate the same message. So depending on the requirements of the journal that you are going to submit your article to, or based on the comments that you receive from the reviewers, you can make a decision about selecting any of these statistics. Note that you need to report the f-square effect sizes. So again, based on the confidence intervals, based on the t-statistic, and also based on the p-value, none of the nonlinear relationships are statistically significant. And with respect to the effect sizes, you would see that there is only one effect size that is almost medium. Alright, it was all about examining nonlinear relationships in a smart PLS. I hope you liked this video, and thanks for watching.